Vector addition. The sum of two vectors, v and w, is called the resultant vector. Visually, we draw the vector so that the initial point of w aligns with the terminal point of v. The resultant vector v plus w starts at the initial point of v and ends at the terminal point of w. So just a quick visual representation of that, just for fun here. So let's say I have vector v. This is the initial point, that's the terminal point. Vector w starts right at the end of vector v. So there's the initial point, the terminal point of vector v. That means that the resultant vector is from the initial point of vector v to the terminal point of vector w. That's what it looks like to add two vectors together, and here's how we get our resultant vector is. Yes, absolutely, because we're going to have an angle and a magnitude, just like we did with the stuff we learned in chapter 6. We're going to use like all the same formulas again, which is why all of this is kind of lumped together in the same test, because we're using it for all different things. Polar coordinates, we're using it for complex numbers in polar form, we're using it for vectors, and we're going to be using it a little bit for parametric equations when we get to chapter 8, which is actually the end of chapter 9. I don't know if you read my announcement that I don't have resources from the new textbook yet, so we're using the old textbook. So chapter 7 and chapter 8 are all chapter 9, and the numbers are all going to be chapter 9 stuff. So hopefully you can adapt to that okay. All right, let's do this example. A plane leaves an airport with an airspeed of 175 miles per hour at a bearing of north 40 degrees east. So I like to make a little compass. And then let me do this some color here. Okay. So our airplane is going, I can't decide what color I want, at a bearing of north 40 degrees east. So let's do it about right there. So change this to my pen. I'm going to label this as 175 miles per hour. And this angle right here is 40 degrees because it starts at north and goes toward the east. That would be easier to see if my pen was thinner. Let's do that. That's sort of better. Okay, next let's do the wind vector, which is blowing at a bearing of south 60 degrees east. So at the end of my airplane vector, I'm going to make myself another little compass just to remember where south and north and east and west are. That's just my tricky thing of making sure I know what I'm doing. Okay, so the wind is at a bearing of south 60 degrees east. So it's going from south toward the east. And that is going to be 35 miles per hour. And this time we came from the south instead of from the north. So that would be this little angle right here is 60. Okay, so using alternate interior angles, if this angle is 40 from north toward east, then this angle from south toward west is also 40. Agreed? Because those are alternate interior angles which are congruent. I wanted a different color. That's what I wanted, right? I just wanted it to be red. I'm forgetting what I'm doing. Okay, there we go. So then the resultant vector would be from here to here. So that represents the plane flying based on its compass this direction, but the wind pushing it that direction. So where the plane actually goes is here. So this all has to be considered in the equipment that a pilot uses to help steer a plane to the right place, right? The amount of wind and from what direction it's going, because that can affect where the plane is actually going. That's interesting. Awesome. Okay, so we want to find the true speed of the plane and the true bearing of the plane. So we want to find this right here. We know a side, we know an angle, and we know a side. What do we use to find that? So to find this side here, I don't know what variable we want to use. It doesn't really matter if we have a variable. We're going to do this. So square root of 175 squared plus 35 squared minus 2 times 175 times 35 times the cosine of 100. And I got 100 by taking my two angles and adding them together because we know that this one was 40 because it's alternate interior to that one, and this angle was 60 for a total of 100 in that corner. Put that in a calculator, and what do we get? That's what I got. Good job. Okay, so then the next thing we're going to want to do is find this angle right here, and then we will use that angle to help us figure out the bearing. I'm guessing that the bearing will be represented from north to east, but it's going to be a different number than the 40 because it's further. So let's find this angle, but then we're going to need to add it to the 40 to get the actual bearing of the plane. So to find this angle, we can either use law of cosines again, or we can use law of sines. I'm pretty sure that's an acute angle. It's absolutely an acute angle because it's between north and east. And so using law of sines would be just fine. So I'm going to go ahead and use law of sines. Sine of theta over the side across from it is 35 equals sine of 100 over the side across from that is the one we just found, the 184. We might want to use a few more decimal places to keep it more accurate. Then 329, sure. Okay. So then theta is going to be the inverse sine of 35 times the sine of 100 divided by 184.329. So we'll throw that in a calculator, and my calculations come out to, see if you guys agree with this, 11 degrees. Why is it 11 degrees? Did you just ask why it is? Did you get it? Okay. Right, because we need to actually add, right, exactly. The angle between the plane vector and the resultant vector is 11, and then we have to add it to the 40 to get the bearing. So our bearing is north 51 degrees east and at 184 miles per hour. So the wind is pushing us a little bit faster than we would be going on our own. Where did my video recorder go? I don't even know where it went. There it is.